Not so long ago, Google was struggling to compete with companies like OpenAI, losing hundreds of millions of customers to OpenAI's ChatGPT model. Fast forward to today, the tables have completely turned.
Sam Altman reportedly issuing this code red to employees to refocus resources into the core product, of course, ChatGPT.
It has been a big day for Alphabet. That stock actually hitting a new intraday all-time high.
Rightfully so, that Alphabet is being anointed this kind of new up-and-coming king of the AI race.
I'm SK, and today we'll look at 6 different arguments as to why Google will win the AI race. The competition in AI is intense, and Google stands out to be a formidable leader, leveraging a suite of strategic advantages that position it for the long-term dominance. Let's unpack the drivers behind Google's transformative success. Starting with the core, the critical role of hardware in AI development. Google's strategic investments in tensor processing units positions the company at the forefront of the artificial intelligence race by delivering unparalleled performance efficiency and cost advantages, fundamentally reshaping large-scale AI operations. Since the inception of TPUs in 2015, Google has iteratively advanced this custom silicon, with the 7th generation Ironwood TPU representing a pinnacle of specialized design optimized exclusively for machine learning workloads. Unlike general-purpose graphics processing units from competitors such as NVIDIA, which incur overhead from versatile instruction decoding, TPUs employ a systolic array architecture that streamlines tensor operations, enabling up to 4.7 times faster performance and 67% greater energy efficiency per watt compared to predecessors. This architectural focus translates into substantial cost savings, with benchmarks indicating 4 times better performance per dollar for inference tasks on large language models, a critical factor as AI shifts from training to widespread deployments. By 2026, with Ironwood's general availability and partnerships like Anthropic's deployment of up to 1 million TPUs, Google is poised to capture a larger share of the AI infrastructure market, projected to exceed exaflop-scale computations. In contrast, competitors like OpenAI and Microsoft remain reliant on NVIDIA's ecosystem, incurring costs exceeding $60,000 per GB200 superchip and facing supply constraints that delay model developments. Amazon's Trainium 2 performs well in inference but lacks the comprehensive training capabilities and ecosystem support of TPUs. Meta's MTIA is primarily used internally, limiting its broader impact, while AMD's MI300 series requires higher power consumption and ongoing optimizations to compete. This hardware advantage enables Google to accelerate innovation, such as training large-scale models in weeks rather than months. As AI evolves towards trillion-parameter systems, efficiency in energy and cost will be paramount, and Google's self-sufficiency provides a decisive edge. The company is not merely participating, it is reshaping the infrastructure of AI. Next, we turn to the models that drive AI applications. Google's Gemini series exemplifies the company's superiority in artificial intelligence modeling, with Gemini 3 Pro achieving unprecedented benchmarks in reasoning, multimodal processing, and practical applications, thereby establishing a benchmark for AI excellence and propels Google toward victory in the ongoing race for dominance. Launched amid intense competition, Gemini 3 Pro has shattered records across multiple evaluations, including a 37.5% score on Humanity's Last Exam and 91.9% on GPQA Diamond, surpassing rivals like OpenAI's GPT 5.2 in PhD-level scientific reasoning and abstract problem solving. This model's multimodal capabilities, evidenced by an 81% on MMU Pro and 87.6% on Video MMU, enable seamless integration of text, images, and video, facilitating advanced tasks such as complex data analysis and creative content generation. In coding and mathematical domains, Gemini demonstrates exceptional precision, with superior performance and benchmarks like AIME 2025 and Frontier Math, where it outperforms competitors by significant margins, underscoring its utility for developers and researchers. When compared to peers, OpenAI's GPT-5, despite its popularity, has encouraged delays and reported shortcomings in video processing, often requiring additional fine-tuning. Microsoft's Phi 3.5 is efficient for compact devices, but lacks the scalability for enterprise-level reasoning that Gemini provides natively. Anthropic's Claude 3.5 prioritizes safety, but trails by 10 to 20 points in image and video benchmarks. Meta's Llama 3.1 appeals to open-source developers, but exhibits inconsistencies and higher hallucination rates. Google's iterative approach, with frequent updates incorporating user data, ensures continuous improvement. As AI progresses towards autonomous agents, Google's focus on holistic intelligence positions it as the frontrunner. Moving on to Google's massive data and ecosystem integration. Data forms the foundation of effective AI, and Google possesses an unparalleled repository. Cultivated through its vast ecosystem of interconnected services, confers a decisive advantage in the artificial intelligence competition by enabling continuous refinement of models through real-time, population-scale feedback loops that no rival can replicate at comparable depth and breadth. Spanning billions of users across platforms such as Search, YouTube, Android, Workspace, and Chrome, this ecosystem generates an inexhaustible stream of high-quality, diverse data that fuels AI development, creating a virtuous cycle where improved models enhance user experiences. Google's ecosystem facilitates seamless integration, allowing AI agents to operate fluidly across devices, browsers, and cloud services while adapting to user behaviors. By comparison, OpenAI depends on web scraping, which invites legal challenges such as ongoing litigation from outlets like the New York Times and results in variable data quality. Microsoft's Azure aggregates external sources effectively but lacks the behavioral diversity, leading to compartmentalized experiences where Copilot in Office falls short of Gemini's cross-platform cohesion. Amazon's AWS emphasizes e-commerce and Alexa data, which excels in retail but underperforms in general knowledge. Meta's social platforms provide engagement-focused data, biasing Llama towards popularity over precision, with open sourcing reducing proprietary control. Anthropic's ethical data sets are commendable, but limited in scale, constraining multimodal capabilities where Claude excels in text but struggles visually. xAI's Grok has Tesla-derived data and data from social media platform X, but it still dwarfs in comparison to Google's data sources. Amid increasing restrictions on data acquisition, Google's proprietary streams create robust feedback mechanisms, refining AI with each interaction while competitors invest heavily in acquisitions. This advantage transforms AI into an integral tool, solidifying Google's leadership in agentic systems. Number 4, Google's comprehensive vertical integration across the artificial intelligence stack. From custom silicon and cloud infrastructure to advanced models and end-user applications, provides the company synergistic efficiencies and innovation capabilities that constitute a formidable barrier to entry, ensuring its lead in the competitive landscape of 2026. By controlling every layer of the AI ecosystem, Google eliminates dependencies on third-party providers, enabling seamless optimization that reduces costs, accelerates development cycles, and enhances overall performance, unlike OpenAI's reliance on Microsoft Azure, which introduces coordination overheads and potential conflicts. This integration begins at the hardware level with tensor processing units, extends through Google Cloud's scalable infrastructure, incorporates models like Gemini, and ends in products such as Search and Workspace, creating a closed-loop system where advancements in one area propagate benefits throughout. Such cohesion allows for co-design of components as seen in the Ironwood TPUs for fold performance gains, which directly bolster model training and inference at lower energy expenditures, outperforming NVIDIA's ecosystem which separates hardware from software layers. In enterprise context, this full-stack approach facilitates agentic workflows where AI agents orchestrate complex tasks across platforms, driving productivity gains projected to reshape business operations. Google's strategy mitigates risk associated with fragmented supply chains, as evidenced by its ability to deploy AI at global scale without the pricing leverage exerted by external chip suppliers like NVIDIA. Google's interconnected ecosystem enables cross-platform interoperability such as the agent-to-agent protocol with partners like Salesforce, enhancing enterprise adoption. This holistic control not only optimizes economic outcomes, evident in 35% growth in enterprise AI revenues, but also aligns with sustainability goals through efficient resource utilization. Ultimately, Google's vertical integration transforms potential vulnerabilities into strengths, creating an environment where innovation compounds, user experiences are elevated, and market dominance is maintained over less integrated rivals. Number 5, their abundant resources, talent, and strategic focus. Google's relentless pursuit of top-tier talent, coupled with substantial research and development investments and targeted acquisitions, fortifies its position, fostering a culture of innovation that drives breakthroughs and sustains long-term dominance in 2026, particularly when benchmarked against competitors' talent poaching challenges and less aggressive R&D spending. Attracting geniuses such as Demis Hassabis and Geoffrey Hinton, Google has assembled a powerhouse team. With DeepMind's acquisition like the $550 million deal absorbing elite researchers who pioneered transformative technologies, outpacing OpenAI's talent drain amid internal upheavals. Recent moves including a $2.4 billion licensing agreement with Windsurf to integrate its AI coding expertise and hire key executives exemplify Google's acquihire strategy, enhancing agentic coding capabilities with full ownership. Similarly, the Hume AI deal brings emotional intelligence advancements, bolstering multimodal models and surpassing Anthropic's focus on safety without emotional AI depth. R&D expenditures projected at billions annually support initiatives like the €5.5 billion investment in German infrastructure, including AI centers fostering 2,000 jobs and advancing quantum computing via the Willow chip. dwarfing xAI's more speculative, less funded projects. Google's AI Futures Fund and $120 million Global AI Opportunity Fund nurture startups and global education, ensuring a pipeline of talent that exceeds Meta's internal labs in global outreach. This ecosystem, drawing from historical talent where nearly all AI pioneers worked at Google, enables rapid iteration on models like Gemini, outpacing competitors like Amazon in foundational research output. Ultimately, this holistic approach to talent and R&D cements Google's AI leadership over rivals with narrower focuses. Finally, the cost efficiency and pricing power. Google's mastery of cost efficiency in artificial intelligence operations, underpinned by proprietary hardware and optimized infrastructure, grants the company substantial pricing power that democratizes access to advanced AI while securing its market leadership through competitive subscription models in 2026, especially when compared to competitors' higher operational costs and premium pricing strategies. By leveraging TPUs, Google achieves up to 4 times better performance per dollar in training and inference. This efficiency manifests in consumer offerings like the Google's AI Pro plan, priced at $19.99 monthly, with promotional discounts reducing annual costs to $99.99 for the first year, bundling 2 terabyte storage and premium Gemini features at a value that undercuts standalone AI subscriptions such as OpenAI's ChatGPT Plus at $20 monthly without equivalent storage perks. For high-end users, the AI Ultra plan at $249.99 monthly provides 30 terabyte storage and elevated model limits, with introductory offers halving costs for initial months, making enterprise-grade capabilities accessible and more affordable than Microsoft's Copilot Pro at similar tiers but with fewer integrations. API pricing further exemplifies this advantage, with Gemini 3 Pro at $2 to $4 per million input tokens, substantially lower than prior generations and competitors like Anthropic's Claude at $15 per million, facilitating widespread adoption among developers. Google's pay-as-you-go cloud model, integrated with agentic tools, ensures scalable savings, as seen in fraud detection applications, outperforming Amazon's Bedrock, which incurs higher base fees for similar services. This pricing strategy not only attracts individual users, but also enterprises, where ROI-driven budgets favor Google's efficient stack. Overall, Google's ability to offer superior value at lower prices stems from vertical integration, enabling reinvestment in innovation and solidifying its dominance over costlier alternatives from xAI or DeepSeek. In conclusion, these factors collectively forecast Google's achievement of AGI-level capabilities by 2030. Yes, there are competitors who are performing well, but no one comes close to Google in the massive scale of their data, or the efficient models, or the pricing control advantage due to their full-stack vertical integration. What are your views? Does Google hold the advantage, or could a challenger emerge? Share your insights in the comments, like if you found this informative, and subscribe for further data-driven analysis. Thanks for watching. I'll see you in the next video. Until then, take care and invest wisely.